Good morning, children. Let's continue exercise 3.2, question number 3. So question number 3, it is given that on comparing the ratios a1 by a2, b1 by b2, c1 by c2, find out whether the following pair of linear equations are consistent or inconsistent. In the first class itself, we have told the given pair of equations will be consistent if they are intersecting or if they are coincident. And on the third conditions, if they are parallel, then the system will be inconsistent. So let's do Roman number 1. So the given pair of linear equations is thrice x plus twice y is equals to 5. So which we can rewrite as thrice x plus twice y minus 5 is equals to 0. And similarly the second one, that is twice x minus twice y is equals to 7, we can rewrite as twice x minus twice y minus 7 is equals to 0. So here a1, b1 and c1 we have taken that a1 is 3, b1 is 2, c1 is minus 5. Again a2 is 2, b2 is minus 3 and c2 is minus 7. So therefore a1 by a2 is equals to 3 by 2, b1 by b2 is equals to 2 by minus 3. That means the minus goes up, so it becomes minus 2 by 3. So since, as we can see here, a1 by a2 is not equals to b1 by b2. So since a1 by a2 is not equals to b1 by b2, therefore the lines representing the above equations have unique solution. Hence the system is consistent, because if a1 by a2 is not equals to b1 by b2, that means the lines are intersecting, and if the lines are intersecting, they are representing unique solutions. Hence the system is consistent. So again, let's see the second one. It is Roman number 2. It is given that twice x minus twice y is equals to 8 and 4x minus 6y is equals to 9. So it is twice x minus twice y we can rewrite as twice x minus twice y minus 8 is equals to 0, and this we can rewrite as 4x minus 6y minus 9 is equals to 0. So therefore we have similarly we have taken the a1 is equals to 2, b1 is equals to minus 3, c1 is equals to minus 8, and again a2 is equals to 4, b2 is equals to minus 6, and c2 is equals to minus 8. So therefore a1 by a2, is equals to 2 by 4, that we can write 1 by 2, and b1 by b2 is equals to minus 3 by minus 6 is equals to 1 by 2, and c1 by c2 is equals to minus 8 by minus 9 is equals to 8 by 9. So here we can see a1 by a2 is equals to b1 by b2 but not equals to c1 by c2. That means this gives the third condition. That means the lines are parallel, and if the lines are parallel, that means we cannot find any solution. So therefore the system will be inconsistent. So therefore we have written, therefore the lines representing the above equations are parallel. Hence the system is inconsistent. So similarly you do the rest and find whether the system is consistent or inconsistent. Now for question number 4, which of the following pairs of linear equations are consistent or inconsistent? If consistent, obtain the solution graphically. So this question you have to do it by yourself. So first you have to find as by taking a1, b1, a1, b1, c1 and a2, b2, c2. Just see whether the lines are intersecting or coincident or parallel. If they are intersecting and coincident, that means it will be a consistent system, and if it is a consistent system, you obtained the solution graphically. So you have to do this one by yourself. So let's move to the next question, that is question number 5. So it is given that half the perimeter of a rectangular garden whose length is 4 more than its width is 36 meters. Find the dimensions of the garden. That means we are asked to find the length and breadth of the garden. So let's take let the length of the garden be x meter and the breadth of the garden be y meter. So according to the question, it is given that length is 4 more than the breadth. So therefore x is equals to y plus 4. If y goes this side, it becomes x minus y is equals to 4. So this is equation 1. Again given half the perimeter is equals to 36. So half the perimeter is 36. So therefore 1 by 2 into 2. So perimeter, we know the formula for finding the perimeter of a rectangle, that is 2 into length plus breadth. So therefore 2 into x plus y. So 2 cancels, only x plus y remains, which is equals to 36. That is the second equation. So now we'll be solving these two equations graphically. So now equation 1 implies x minus y is equals to 4. Therefore x is equals to y goes to the other side, it becomes y plus 4. The two coordinates which satisfy the above equations are tabulated below. That is x and y, that is a coordinate a, that is 4, 0, and b, that is 6, 2. Similarly, from equation 2, x plus y is equals to 36, x is equals to 36 minus y. So therefore, two coordinates which satisfy the above equations are tabulated below. So therefore, the two coordinates are p, that is 20, 16, and q, 12, 24. So let's represent this on a graph. If you plot these points on a graph, so this is a, that is 4, 0, b, which is 6, 2, again p, which is 20, 16, and q, 12, 24. Now just join this point AB, and we just extend it a little bit. Again we join this P and Q and just extend. So after extending, we saw that both the lines intersect at this point, that is P 20, 16. So therefore this will be the solution of the above equation. So the solution of the above equation will be 20, 16. So let's write this. So the points A4, 0 and B6, 2 are plotted on the graph paper. On joining these points, we obtain the line AB, which is the graph of the first equation. Similarly, the points 20, 16 and Q 12, 24 are plotted on the graph paper. On joining this point, we obtained line PQ, which is the graph of the second equation. So it is seen that the two lines, that is AB and PQ, intersect at the point P 20, 16, which is the required solution. So hence x is equals to 20 and y is equals to 16. So therefore, since we considered x as the length and y as the breadth, so therefore length is 20 meter and y is equals to 16 meter, that is breadth is equals to 16 meter. Then question number 6. So given the linear equation twice x plus thrice y minus 8 is equals to 0, write another linear equation in two variables such that the geometrical representation of the pair so formed is intersecting lines, parallel lines, and coincident lines. That means one of the equation is already given, so we need to give an example of another equation such that the lines will be intersecting, parallel lines, and coincident lines. So it is up to us how we give the example. So we'll be doing the first one, that is Roman number 1, intersecting lines. So given twice x plus thrice y minus 8 is equals to 0. So therefore number 1, intersecting lines. So we have taken this one as 5x minus y plus 3 is equals to 0. That means this is the example that we have taken by ourselves. That is 5x minus y plus 3 is equals to 0. Why we have taken? Let's check. Here a1 is equals to 2, b1 is equals to 3, and c1 is equals to minus 8. And similarly a2 is equals to 5, b2 is equals to minus 1, and c2 is equals to 3. So therefore a1 by a2 is equals to 2 by 5. Again b1 by b2 is 3 by minus 1 is equals to minus 3 by 1. So which is equals to 3. Now we can see that a1 by a2 is not equals to b1 by b2. So therefore, since a1 by a2 is not equals to b1 by b2, hence the lines are intersecting. So similarly, you give examples for parallel lines and coincident lines. So it is up to you how you give the example. So you have to do this Roman number 2 and 3 by yourself. So let's move to the next question, that is question number 7. Draw the graphs of the equations x minus y plus 1 and thrice x plus twice y minus 12 is equals to 0. Determine the coordinates of the vertices of the triangle formed by these lines and the x-axis and state the triangular region. That means first we have to give a graphical representation for this given pair of linear equations, and after that we will see that the graph does the line segments, the two line segments formed by these two linear equations will intersect with the x-axis, thereby forming a triangle. So we have to shade the triangle and name the coordinates of the triangle. So it is given that x minus y plus 1 is equals to 0. So this is the first equation. Again yes, this is the first equation. Again thrice x plus twice y minus 12 is equals to 0. So this we can write as thrice x plus twice y is equals to 12. So this is the equation 2. Now equation 1 implies, so x minus y plus 1 is equals to 0. So therefore we can write like this. So x is equals to, y goes to the other side, it becomes plus, and this 1 moves to the other side, it becomes minus. So y minus 1. Therefore, the two coordinates which satisfy the above equations are tabulated below, that is 0 and 1. If we put in place of y, we put 1, so 1 minus 1, it becomes 0. If we put 2 in place of y, 2 minus 1, it becomes 1. So the coordinates are a 0, 1 and b 1, 2. Again, equation 2 implies, so what is the equation 2? Equation 2 is thrice x plus twice y is equals to 12. So therefore we can write x is equals to 12 minus twice y by 3. Therefore the two coordinates which satisfy the above equation are tabulated below, that is p 0, 6 and q 2, 3. So now let us put this coordinates on a graph. So this is a and this is b. So this is p and this is q. So after plotting, we see that when we extend this AB a little bit, so it cuts the x-axis at minus 1, 0. And similarly, PQ, when we extend the PQ, it cuts x-axis at the point 4, 0. So therefore, we can see that QRS, so this is a triangle that we have shaded. So thus it forms a triangle, that these two lines forms a triangle with the x-axis. So that is triangle QRS. So the point A 0, 1 and B 1, 2 are plotted on the graph paper. On joining this point, we obtain the line AB, which is the graph of the first equation. Similarly, the points P 0, 6 and Q 2, 3 are plotted on the graph paper. On joining these points, we obtain the line PQ, which is the graph of the second equation. So it is seen that these two lines intersect with x-axis and forms the triangle QRS. So this is the triangle QRS, which is shaded. Hence the coordinates of triangle QRS are, so what are the coordinates of the triangle? It is Q, that is 2, 3, R minus 1, 0 and S 4, 0. So that's what we have written here, R Q 2, 3, R minus 1, 0 and S 4, 0 respectively. So that's all for today. So remaining we will discuss in the next class. Thank you.